So in this problem, we are asked to determine if an undirected graph is a bipartite. So a bipartite graph is a graph where all its nodes, we can divide it into two groups. So all the nodes within the same group, it cannot have edges connecting to each other. So we solve this problem by using breadth first search. So basically, we have a root node, or any selected nodes in this graph, and we use two colors to represent two groups. And if the two nodes have the same color, then it means they're in the same group. If the two nodes have different colors, then it means they're in a different group. So we have our root node, we color it with one color, and then we color all its neighbor with the second color, and we color the neighbor of its neighbor with the first color again. And we just keep doing that until we find a conflict that the two nodes are having the same color. Then we know it's not a bipartite, because if two nodes have the same color, then it means they're in the same group, and there are an edge connecting them. So this whole graph is not a bipartite graph. So in our implementation, we first we have a hash map from a graph node to integer. Basically, this is to keep track of the color of each graph node. And the other thing is we run a breadth first search for each node in this graph, because we're not guaranteed that this graph is a connected graph. So it could be that, if we start with random node in a graph, we cannot just traverse the whole graph. And so we need to actually go to each node and do breadth first search. And the trick here to make, so we don't actually need to do breadth first search n times, is that here. So we check if this node has been traversed before we do any BFS. And if it has been traversed, then we can just we check this hash map, and if this visited hash map has this node recorded as traversed, then we can just return true. So we don't need to traverse it again. And so basically, we go through each node and we breadth first search. And so there are actually two cases, right? First case, if this node is traversed, then we can just return true. In the second case, if this node is not traversed, then we do BFS. And if the BFS is false, then we are guaranteed that this graph is not a bipartite graph. However, if it returns true, then we are still not sure, because it only shows that this part of the graph is bipartite, but it might have another not connected part of this graph that's not bipartite. So we still need to keep doing breadth first search for each node. And so basically for this breadth first search function, we pass in the parameter, we pass this current node that we start as a root, and we also pass a hash map from a graph node to integer recording the color of each graph node. So here, as we said before, if this node has been traversed, we don't need to do BFS, and we can just return true. And so in this breadth first search, we use a queue to help us through the process. We first do initialization. We initialize this queue, and we enqueue the first node, our root, and we also record its value, record its color as 0. We use 0, 1 to represent two colors. So now, while the queue is not empty, we can just keep expanding and generating. So we first expand the current node from the first out from the queue, and we check our hash map to get the color of the current node, and then we calculate its neighbor color. So if this color is 0, then its neighbor color should be 1, and otherwise it should be 0. And then after expanding this current node, we can generate all its neighbors. So for all its neighbors, there are actually 3 cases. The first case, if we have not generated this neighbor before. So in this hash map, we can't find this neighbor. So we can just put the neighbor and its color in the hash map. We just label this. We just label this node with another color than the current node, and we also put it in the queue. And the second case is that if we have generated this neighbor before, and also it has the same color as current node, right? So the color, we can check the hash map, and the color of this neighbor is not the neighbor color that we expected. So now it has the same color as the current node. So we return false, and the whole graph is not a bipartite. And the third case is that if we have generated this neighbor and it has different color than current node, then we know that it's probably another node that we have generated before, and it's probably where we come from. So we don't really need to generate again. And we do so because we want to avoid duplicate. We want to avoid getting stuck in an infinite loop. And then if we finish traversing the whole graph and we still didn't return false, we still didn't find any conflict between any neighbor nodes, then we can say that this part of the graph is a bipartite graph, and we return true for the breadth first search.